going to get started there. So one of the things that I thought of is what happens if we were to go to... How far out do I go? Okay, I leave when I go that far out. Okay, so I need to stay inside the chair. We find planets outside our solar system. What would it look like if we were on one of those planets? In fact, a lot of people thought, especially as we started developing telescopes, that, oh yeah, Mars, that's just teeming with life, because we saw things that looked like canals and rivers and stuff, and so we just assumed that planets are going to be habitable. In fact, if you go look, there's this, I think I got it down there, the PHL, Planet Habitability Laboratory down in Puerto Rico, the website's out of there. But they have this list of habitable exoplanets, potentially habitable exoplanets ranked by the Earth. And you see you got Neptune, Mars, Earth, and there's Jupiter there for reference. And you got some that look cloudy, some that, I mean, you've got these planets that, where is Earth in there? Oh yeah, there's Earth. So you see, compare it to Earth, they're similar in size, look like they've got a lot of land mass on them. Some of them may even have water on them. In fact, as you scroll down on the website, you see planets, or this image was there. It's like Kepler 186f. That's one of these planets that we think might be habitable and Earth-like. And we got images like that. You scroll down below it, and you see, so just not playing funny with you there. For whatever reason, they switched the images, so now Earth's on this side. But you see what a sunset looks like on Earth, and here's what the sunset looks like on Kepler 186f. How can there not be life on that planet? No, seriously, how could there not be life on that planet?
God didn't make it.
God didn't make it?
Well, he didn't make the life on that planet.
He didn't make the life. He didn't make the life on that planet. So God made the planet. He didn't make the life on the planet. Okay, all right. Cooper.
How far away is that planet?
300 light years tops.
How did we get the picture?
That's a great question. How did we get that picture? Yes, Kate. It's edited. Are you sure? So you're seeing it in there. It's interesting how it's got the same islands that are out here on Earth, you know? Now, in fairness, if you read, what they say is that this is what a sunset would look like on that planet if everything were like Earth. So it's a recognition that the star that this planet orbits is a red dwarf star instead of a yellow star we orbit. And so in that instance, you're going to get a whole lot of red light. You're not going to get all these other colors, and it's just going to look different. But you look at that and you think, okay, yeah, there's water there. Of course there's going to be life. Cooper.
So the reason why I asked that is because how do we know if this planet has the same type of fine-tuning that Earth does?
Well, we don't. That's the short answer to that question is we don't, because we know very little about other planets outside our solar system. What we know about them are mass, orbit, radius, those sorts of things. We have no idea whether there's any water on any of these other planets. So in fact, here the same thing they show for all of these different planets. Again, the reason why I bring this up is that I want you to be discerning when you see things. And just because you see it doesn't mean it's actually there. This is not what Gliese 667c looks like. It's what Earth would look like if it orbited that star. Because this is all Earth, that's the light from the star. So just be careful when you hear and see that. And part of the discussion here is just helping you to see what is it that we know, what is it that we don't know, and to recognize what God has actually done here. Because this is a list, not a list, it's a diagram of all of the planets that we have found so far. And if I'm honest, it's all of the planets we found back in 2018, I think was when I made this image. Maybe it's 2020. But what you notice is that here's mass of the Earth, and this is a logarithmic scale, which means that if this is Earth mass, this is 10 times, 20, or 100 times, 1,000 times. And here's the period, so there's 100 days, 1,000 days, 10,000, 100,000. This is all of the planets we found. What you notice is that it's empty down in this area, right? Because those are really hard planets to find. And if we put the planets from our solar system on this graph, You notice that most of the planets in our solar system hang out down in this we can't detect range. So anytime you hear, ooh, we found this latest exoplanet, it's habitable, just recognize, let's have a little bit of caution and skepticism about all of that, because we don't actually know whether it's habitable. What we know is that it's far enough away from its sun where it's potentially habitable. And I'm going to give you a little bit of insight today as to what it takes to make a planet that is actually habitable. Because we have Earth, or we have dirt, we have air, we have water on our planet in abundance, and turns out those are really hard. Those three things, though we take them for granted, are crucial to the way life works. In fact, the fact that they work the way they do here on Earth is crucial for life here on Earth as well. And so let's take a look at just each of those three in order. So here's water. What do you know about water? What's fascinating about water to you?
Three different states.
Three different states, which are?
Solid, liquid, gas.
Solid, liquid, and gas. Is it important that that water has those three different states?
Yes.
Do you know why?
In general, but not.
Okay, what do you know, Lexi?
We need ice so that we have water later when it's hotter and whatever. We need the steam to go back in the atmosphere to come back.
Okay.
There's water. We need water that's actually water to drink.
Okay, so it seems like all of those three states do play an important thing. In fact, one of the things that I find interesting is that in the creation account, what is the first thing that God does on earth?
Hovers over the water.
That's the initial conditions. What's the first thing that he does?
Separates light and darkness.
Separates light and the darkness. What's the second thing that he does?
Separates water from water.
Separates the waters above from the waters below. So whatever was going on with water, notice too that the presence of water doesn't make things habitable. What does the earth look like in its earliest states while it's uninhabitable?
Water.
Well, let's read, what does Genesis say? In the beginning, God created the heavens and the earth, and the earth was formless and void. It's uninhabitable, formless, hostile to life. The earth was formless and void.
I mean, it wasn't a circle. What does formless mean?
I'll get to that in a second. Let me finish this thought here first. What's the rest of that verse? And the earth was formless and void.
Darkness was over the face of the earth.
Darkness was over the face of the earth.
And the Spirit of God was hovering over the face of the water.
Over the what?
Waters.
So you've got this formless and void, hostile to life environment, which is dark, but yet it's covered in water. So we have this idea, find the water, where you find water, you're going to find life, right? That's not what I expect looking at things scripturally, because even though the earth is covered in water, it's still hostile to life. God's still working to make that water. In fact, what he does on the second day is separate the waters above from the waters below. Now, I think what he's doing there is making a stable water cycle so that there's always this continual supply of refreshing water, which is going to make the fresh water, which a lot of us, well, we certainly need for life, a lot of life needs. And so this is just a place where it's actually showing you the different states there. There's the liquid water underneath. In fact, one of the things that we find about water is that it is one of the few substances that freezes top to bottom. You ever put a bottle of water in the freezer? What happens to it?
Eventually it freezes.
It freezes, and if you cap it off with no room, what happens to it? It expands. Water is one of the few substances that expands when it freezes. And because it expands when it freezes, what happens is as it gets colder and colder, you would expect that to go deeper and deeper in the water because it's going to get more and more dense. But right before it freezes, there's something that happens in the water that actually makes it get less dense and all of the ice floats to the top. What happens to life inside lakes if that doesn't happen? If water freezes like all the other substances from the bottom to the top, what happens to all the life in a lake? It dies. Does the lake ever thaw? No. Well, it's got to be a really, really warm temperature because for the warmth to penetrate down to the depths, it's got to be able to melt increasingly more and more ice, and that's really hard. So water has a whole bunch of properties that make it really favorable to life. In fact, it is responsible for one of the reasons people like to live here. What's true of the temperature here?
Constant.
Constant. Do you know why it's constant?
The ocean.
What about the ocean makes it constant?
No idea.
No idea. You are correct. You are correct. What is it about water that makes Hawaii's temperature so constant? Humidity, that helps, but that's a secondary effect. What happens when you add heat to water?
That heats up.
It will heat up. Do you know that water has this thing called a heat capacity? And the heat capacity is just basically how much heat do you have to add before the temperature of the water changes? Water has one of the largest heat capacities. In fact, it used to be what we use in radiators because you could heat water up a lot and it wouldn't change its temperature very much. Or you could add a lot of heat to water and it wouldn't change its temperature. And so Hawaii is surrounded by this huge body of water which serves to keep the temperature of the islands very, very constant. And it actually plays, the water as a global thermostat. It keeps the temperature of the globe very, very constant overall as well. And so this is not just a run-of-the-mill substance. It's actually critical for the way life works. And I want to just kind of get into that. You know, here we've got the water cycle, just talking about water throughout Scripture. It's very prominent throughout Scripture, water is. For they deliberately overlooked the fact that the heavens existed long ago, the earth was formed out of water, through water, by the word of God. That just having water is not necessary, or not sufficient for life. God works to make the water so that it works for life. And so, you know, I just love water. This is a picture I took while I was out deep sea fishing in the Gulf of Mexico. We were out catching wahoo that day, if I remember correctly. But, you know, just fascinating water there. Here's a waterfall coming in off the Mendenhall Glacier up in Alaska. And you just kind of see the power. I mean, you're standing here, and if you stood 10 feet this way, it was warm. But if you got out here where the blast of air coming off the water was, the temperature dropped about 10 or 15 degrees. So it's just fascinating the water is. And then water floats, you know, these cool, it's just pretty fascinating substance all said and done. And so what is it that gives water its extraordinary nature? So here's a little bit of science for you. What's water made of? Hydrogen and oxygen, specifically H2, yeah, 2 hydrogen, 1 oxygen. And so you would think normally you've got 2 hydrogens on an oxygen. You would think that normally the hydrogens would be opposed to one another. So it would be this nice straight line molecule. Turns out it does not work that way because of the way God has structured things. And actually what you have is the oxygen, and then the hydrogens are actually, I think, at about 104 degrees, which is an odd number. It's not an expected number. But what that means is that you've got these 2, okay, a little bit more detail. So oxygen has 8 electrons that it has to deal with. There's one that's bonded to the hydrogen, one that's bonded to or one over there, and then it's got these 2 pairs over here, so that gives it 8 total electrons that it's dealing with, because it borrows one from the hydrogen. But you've got these 2 electron pairs down there, and that means that this side of the oxygen is negatively charged, or sorry, this side of the water is negatively charged, this side of the water is positively charged. And so that's going to attract, not a chemical bond, but it's going to attract the water molecules together. Is that a question or just a hand? All right. And so you've got the positive part of the hydrogen bonding to the negative part of the water. And that means that water is actually liquid at the temperature where we are. Because if you look and you ask the question, what should it do? Well, here is, here's H2 with tellurium, H2 with selenium, H2 with sulfur. Those are the elements right below oxygen on the periodic table. But yet when we get to oxygen, it goes way up here. And that's because it's got this weird hydrogen bonding going on. You would expect it to be down here, which means its boiling point would be minus 100 degrees Celsius, which is really, 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 really cold. So it would boil, it would just be vapor all the time. But water actually behaves so that its boiling point is up at 100 degrees Celsius. All that to say is that God has structured, we see this fine-tuning built into the way water works so that it has all of these fantastic properties that are critical for life. It's what's called the universal universal solvent. It will dissolve almost everything because it's got this slightly polar nature. It has a very high heat capacity, which regulates heat. It freezes from the top to the bottom so that it doesn't freeze everything solid and just that way. It's very high reflectivity when it's in its gaseous or in its solid state, and a very low reflectivity when it's in its liquid state. And so it just has all these remarkable properties that make Earth a habitable place. And so while we're inclined to take it for granted, we see God's fine-tuning and design when we look at the nature of water. So we said water is one of those things we take for granted. Well, air is another thing we take for granted. What is the air on our planet made of?
Oxygen.
Oxygen. It's about 21% oxygen. What else?
Nitrogen.
What?
Nitrogen.
Say it again.
Nitrogen.
Nitrogen. It's about 78% nitrogen.
Carbon dioxide.
Carbon dioxide, and a whole bunch of other stuff. So that last 1% is a whole lot of other stuff. Remarkably, that 1% has a whole lot of influence on how our planet behaves. And so if we're going to have the oxygen the atmosphere that we have, we've got to have oxygen. Do you know where in the universe oxygen is produced? That recycles it from one chemical form to another form. So it takes it from carbon dioxide and makes it free oxygen. But where are the oxygen atoms themselves made? Comets? No?
Is it anything to do with the ozone layer?
Nope. Ozone is just 3 oxygens put together. So that's a particular form of oxygen. But where in the universe are the oxygen atoms made?
The cloud things?
No? They're made in stars.
Star.
When our universe first formed, it was mostly hydrogen, little bit of helium, and virtually none of the heavier elements on the periodic table. All of those heavier elements are made inside stars. And it turns out that if God had not structured things in a particular way, there would not be very much carbon and oxygen in our universe. So when we look at the heaven, we see the heavens declare the glory of God. The sky above proclaims his handiwork. One of the ways we do that is when we look at our atmosphere. We look and we see I just love this picture because it's kind of like the Star Wars ocean there. I mean, you've got the light side and the dark side. In stars, the way carbon and oxygen is made, a little bit of science, that you've got hydrogen is 1 proton. Helium is typically 2 protons and 2 neutrons. That's an alpha particle, where we just a helium. So this is a helium nucleus here. Carbon has 6 protons, 6 neutrons. So you got to get 3 of these put together to make a carbon atom. And the problem is getting 3 of these things to come together at the same time is really, really inefficient. It doesn't happen very quickly. But it turns out that if you take 2 of them and put them together, they'll make this thing called a beryllium-8 nucleus. It's not stable, but it kind of sticks around for a while. And then eventually another one of these helium can come in and make carbon. And as scientists have studied how does this process happen in stars, what they recognize is that if this was stable, we would have virtually no carbon in the universe. Or rather, we would have no hydrogen in the universe. If carbon didn't have certain energy levels in it, this process would happen way too slowly and there would be virtually no carbon in the universe. And if the next thing that's there, so if carbon runs into another helium, what element does it produce? Does anybody know? Huh? So if you go up from carbon by a helium, you get to oxygen. So if you've got this is this design or kind of fine-tuned state, carbon has some fine-tuned stuff in its state, and oxygen, if it had the same fine-tuned state, all of the carbon would get made into oxygen. We'd end up with no carbon in our universe. Can you have life in a universe without carbon? No. Question?
So if oxygen comes from stars, how do we get oxygen on Earth?
So what you have happen is the first generation of stars were just hydrogen and helium. They made carbon and oxygen and those sorts of things, blew up. Stars, especially those first stars, are going to blow up pretty quickly. Then a next generation of stars is going to get made. And then they're going to burn for a while, and then they're going to blow up. So our star is actually a third generation star. So it starts with only hydrogen and helium. Stars make all the other elements, blow up, and then they get incorporated into the later stars. So our planet formed from a third generation, or our star is a third generation star. So it has a lot of the hydrogen, oxygen, carbon, nitrogen, those sorts of things that are necessary.
Yeah, but why is there so much oxygen on Earth compared to other planets in our solar system if we're all orbiting the same star?
There isn't so much oxygen on Earth. What's unique about Earth is that the oxygen is in its free state as opposed to combined with something else. So Venus has a very, very dense carbon dioxide atmosphere. So all of its oxygen is tied up in the carbon dioxide and in the elements, the materials inside the planet. Earth has oxygen in its atmosphere because there are processes that take the oxygen out of that other form and release it up into the air so that we can breathe it. So it's not that our planet has more oxygen, it's that our oxygen is in a way that allows us to breathe it and use it. And incidentally, we breathe oxygen in and we exhale carbon dioxide. So we convert oxygen from its free form to its waste form, which is carbon dioxide, but God has designed plants to do the reverse of that process so that we can breathe it in again. But as the whole point of all of this is that just the same way when we were looking at water, we see evidence of fine-tuning and design. When we're looking at carbon and oxygen, we see evidence of fine-tuning and design as well. But we also, because we have this atmosphere that has water and carbon dioxide and oxygen and nitrogen in it, we get things like this. Now I'm curious, what do you think that picture is? You guys are too easy. That is exactly right. It's a sunset of clouds where there's just these wispy clouds all along, and the sun's coming along underneath, and it just looks like the sky's on fire. I got a little light pole in there just to let you know that it's actually a picture. I mean, we just see the beauty that God has put in to our creation. Not just the fine-tuning and the design do we see here on Earth, but we see this beauty that he's put into creation that reveals more about who he is than he's not just an engineer, he's an artist also. And so we need water. So, we got water, so we talked about water, we talked about air, dirt, that's the last thing. Let's see what we got with dirt. So dirt, again, it's critical to... Little dirt don't hurt, that is true, and if you don't have dirt, we can't do a lot of the things that we want to do here. And we take our dirt for granted. Dirt is not all dirt. Everybody ever seen the movie The Martian?
Oh, yeah.
So Mars has soil, and I'm going to put that in quotes because it's got small stuff that's in the form, but it's not dirt like we have here on Earth. We've got this dirt that is really remarkable, and we see evidence of fine-tuning in how the dirt is made. That great is our Lord, abundant in power. His understanding is beyond measure. Because the reason why we have dirt and not ground up rocks is because of plate tectonics. We live on a planet where it's not just this static entity where it's covered in water and there's an atmosphere, but lo and behold, the Earth has these huge plates that are moving and grinding back and forth. That's why Hawaii is a series of islands, because there is a very hot spot in the Earth's mantle where new stuff is rising up and the plates are moving across it. And where a plate is moving, it'll build up an island, and then that island will move on, and then a new island's being built. And if I remember correctly, there's another island that's in the process of being built about 1,000 feet below sea level out there. So there's this plate tectonics is what allows Earth to have this abundance of dirt that we have out there. So we see fine-tuning in it. We look at Alaska. This is actually one of the largest elevation ranges you get to see on Earth, because that's a 15,000 foot peak, and you actually see it from sea level. So you get to see the full 15,000 feet there. I think if you go over to Mount Everest, like I said, it's 30 or 29,000 feet, but you're starting about 17,000 when you're looking at it. Yeah, Trish. That's a great question. I don't remember. It's one that you can see off the coast of Alaska. I know that much. Because this is an ocean, not a lake there. I just don't recall, sorry. So.
She's from Alaska, so that's what she's asking.
What, do you know what it is?
Not from the picture. You've got a lot of mountains.
Alaska does have a lot of mountains. Like I said, I'm pretty sure this one was right around a 15,000 foot peak, but I'd have to go look and see where we are. It's in the Glacier Bay area. I know that area because that's where we were on our cruise when I took the picture. So. But when we look at what does it take to make plate tectonics work, what you need to make it work is you've got to have these rigid plates that are not too thick and not too thin, and you've got to have a more malleable, more fluid substance that they can kind of float around and move around on. And normally, as you go down deeper in, the pressure goes, the density increases, and what will happen is it just uniformly does that. But so here I've got, with depth, the amount of water that is soluble in the rocks. Now we normally think of rocks dissolving things, but it turns out rocks can actually dissolve water. And what you'll notice is that there's this little bump right in there. And that bump is related to the types of minerals and elements that are on Earth. They happen to have this particular feature that when it gets down to that temperature and pressure, instead of absorbing more water, they are unable to absorb it. It draws water from above and it releases here, so it makes these relatively thick plates sitting on top of a more malleable fluid substance. If Earth was larger, the plates would be thicker and they wouldn't move around as much. If Earth was smaller, the plates could get thinner and they would move around and you'd have a whole lot more tectonic activity. But it turns out we see, even in the amount of tectonic activity, we see design or fine-tuning here on Earth that God has built this for a purpose, built this planet for a purpose. But we also see that beauty and splendor in there because that plate tectonics is what allows different types of layered sandstone type rocks to form, different crystals to form. I had the opportunity to go out to Washington, D.C. with my family, and there's the Museum of Natural History out there just has this whole room full of crystals and rocks. And both my daughter and I have hundreds of pictures of rocks because they're shiny and pretty. And so there's just a little bit of a sampling of just the diversity and the beauty that we see from what God has done through plate tectonics. But we also see the power in there. This is down in Guatemala. It's I think it's down in Antigua, where there's this volcano, fairly active volcano. But if you think what's going on, what is the most powerful thing we as humans have built or can do? Atomic bomb, that's pretty powerful. It's capable of leveling, a couple of mile diameter pretty easily, if not more. Anything more powerful than that?
Hydrogen bomb.
Hydrogen bomb, that's even bigger. That's capable, take that out maybe to 10 to 15 miles. Think what goes on routinely in our planet. There are, Volcanoes? Well, we can't control them, but we can understand them. You see volcanoes that can erupt. When they go off, they can just explode square miles worth of material out into the atmosphere. And it routinely happens. We've got these huge plates that are thousands of miles long, hundreds of miles deep, that routinely move over the earth. And you think about God sustains creation. He just moves mountains, builds rocks, builds oceans, all of that. His power is reflected in what we see as he's built the earth for us here to live. Yeah, Nick.
Would you say that natural disasters are more dangerous than atomic weapons?
Natural disasters have the capacity to do more damage. Atomic bomb, let's hear, say I drop it on Los Angeles, I can kill tens of millions of people. A natural disaster, depending on the scale, some of the natural disasters that occurred in the history of in the world, could destroy the entire population of humanity, so billions of people. So natural disasters can be more devastating. What you will find is that in the natural disasters, more often than not, the damage that comes is because humans have not behaved responsibly. So, for example, hurricanes routinely hit Florida. Or no, I have a better example than that. Earthquakes and tsunamis happen. They're just a part of plate tectonics. They're the way God has designed things. There was a magnitude 6.7 earthquake that hit Haiti a number of years back, killed 250,000 people. There was a magnitude 9 earthquake, 1,000 times more energy in the earthquake, that hit Japan. In the earthquake, nobody died. In the coming tsunami that they didn't quite design well enough for, 10 to 20,000 people died. So why is it that this enormous earthquake hits Japan, nobody dies, it just overwhelms the tsunami? The tsunami was bigger, and that's what caused some deaths. But even then, a few thousands, as compared to a relatively small earthquake hits Haiti, and hundreds of thousands of people die. Well, it's because Japan invests the infrastructure. They know earthquakes are going to happen. They build to earthquake codes. They may not have built well enough, but they build expecting them to happen. Whereas in Haiti, you don't get that sort of stuff happening. The corruption there in the government keeps it from happening. So I don't know exactly how to answer your question. I do know that in terms of natural disasters, most of the time, the death and destruction that comes from the natural disasters at this point is a lack of humanity accounting for what's inevitably going to happen. I don't know what the particular danger is here on Hawaii, but I know where I grew up, the Missouri and Mississippi rivers routinely flood. Most of it is because people have built their houses down in the floodplains. You can avoid all of that damage by not building in the floodplains. The problem is the floodplains are cheap, easy land to build in. But you know the floods are going to happen, so you don't build there, and none of the damage happens when it floods. So, does that answer your question?
Yeah, it was just out of curiosity, really.
Yeah. Yeah, the downside is there are natural disasters that are capable of destroying the capacity of Earth to support life. And there is no way humanity has the capacity to destroy, no way humanity has the ability to destroy Earth's capacity to support life. We could try, and life will still get by. God has designed Earth and life so well. So we see, just as we look at these routine things, we see in the water, the air, the dirt that we have, these things that we take for granted, we see God's fine-tuning, his design, we see his beauty, his artistry, we see his power, and we just realize that God is just an awesome God. A little side relief here. How many people are there? How many kinds of people are there? You say one. Why?
Because everyone's made in the likeness of God.
Everyone's made in God's image, all right? Everybody gonna go with that answer? Okay, there's my answer. What's that? So in binary, 0, 1, 2. 1, 0 is 2. So in binary, that's a 2. No, there's just those who understand binary and those who don't. Those who understand binary get the joke. Those who don't understand binary don't. Sorry. It was a lot funnier when I read it the first time. So. But I just to kind of bring it back, we see in the way this planet operates, just the things that we take for granted, we see, O Lord, our Lord, how majestic is your name in all the earth. You have set your glory above the heavens. And he's given us the capacity to understand and explore and know this creation, to see him not just as the engineer who designed the planet, but as the artist who not only designed the planet to work well, but artisted the planet, but I'm going to make it up a word, artisted the planet so that we can enjoy his creation. We've got beautiful sunsets, incredible scenery, majestic mountains, but that we also appreciate the power that God has. That I find it interesting that we have this idea that we're in control of what's going on. And the reality of it is the things that God does just without thinking about it are so far beyond the most spectacular and impressive things we can do. God just does. And so by exploring the planets that we see out there, this search for looking at how the universe works, we can just get a much bigger picture of who God is. And this is the same God who cares about us. Think about that. Think about that. Any thoughts, comments, questions? No. Lexi,
Same question I started with.
which was your question? What question did you start with?
So if the earth was formless and empty and water covered the surface of whatever was there, was the world round at the beginning or was it not? If it was formless, how could it be round?
Well, flat is just, so what that's referring to is when we look at Earth, we see mountains and structure and all sorts of stuff. But Earth in its original state, that formless and void has the formless and void connotation, but it also has this hostile to life. And I think that's probably the main meaning there, is it says the Earth, when God created it, it was hostile to life, it was dark, and the Spirit of God was hovering over the surface of the water. So in that original state, now when you see what God talks about through the rest of the creation account, he's transforming the darkness into light and day, night and day. He's transforming the covered in water into a water cycle. And he's transforming that hostility to life, formless and void, into a planet that now has continents and water and
Okay, so
all this
that
sort of
was
stuff.
my other question. My other question is the water that gets separated. It says God separated the vault from under the vault, from above the vault, from all the vault sky. Is that water like on the earth and water in like the atmosphere, or is that water in heaven?
I take it to, I think to me, what makes the most sense there is it's the water on the earth and the water above the earth. So it's the clouds and the water vapor and all the stuff, stable water cycle. Because what's remarkable is that when we look at Earth and Venus and Mars, or rather Venus, Earth, and Mars, if the sun's over there, all of them started covered in water. We see evidence of that clearly on Mars, and in Venus almost certainly is the case. But Earth still has this, is still covered in water with this incredible water cycle. Venus, or Mars, lost all its water early in the early months of the atmosphere. Venus wasn't going to be able to hold on to it in the first place because of some of the last things that happened in its formation. That formless and void water-covered place still needed work so that it actually is capable of hosting life. It's not just this amorphous water that's out there. There's liquid water and gaseous water, and they're exchanging between them and recycling and all of that. So yes, the Earth was round, because any body the size of the Earth is going to be round. It doesn't. The formless and void refers to there's not a clear defined surface where there's above and below. There's not mountains and oceans. There's just stuff.
And then furthering that, God said, "Let the water and the sky be gathered in one place, and let dry ground appear," and it was so. Was the land already there, underneath all that water in the middle, or did He like just create land and separate water? Or do we know?
What I would say is the Earth is going to be covered in liquid water, and there's going to be things that form the land. The processes that form land are volcanic activity will build up landmass, which will then be eroded away, and the process of these plates moving next to each other builds up continents eventually.
So there's plates in the middle of this Earth.
Well, there's plate tectonics going on the Earth. And then, oddly enough, I just read a paper the other day that one of the things they say may have jump-started all the continent formation was a large asteroid impact on the Earth. And so that may have been what God's doing there to get the continents to form, is using that as part of the process. But the separating the waters and the making the land, I think that's a description of continent formation and what God did to make sure there are continents on the Earth. Believe it or not, continents are less dense rock that floats on top of the mantle. So once you've got continents, they erode down, but they keep getting built back up through plate tectonics.
What's the mantle?
So on Earth, you've got the atmosphere, you've got the surface, you've got the crust, which is about 100 meters deep. You've got this plate, that's where the plates move. The plates are the crust. And then you've got what's called the asthenosphere, which is that malleable, what they float on top of. And then the rest of it down to the core is the mantle. And so all of the plates, the continents, float on top of that. We think of continents being made out of rock that's heavy. They're less dense rock. They float on top of all the other rock. That's why they're continents.
Like, what is it?
It's just it's molten rock.
Oh, okay.
Yeah. Sorry, that's not right, Blake.
This isn't like relating to like theology and science. It's kind of just a question.
Sure.
But is the water that's in the crust of the earth, is that considered part of the water cycle?
So yes and no. No, in that the water that we see that rains, evaporates, comes down, gets cycled. I think that's the water cycle that's being talked about on day 2. But all of that gets cycled through the continents and back up. And so there's this much larger water cycle, water that's on the earth gets cycled down and comes back up. And so that's part of that process. But when we talk about the water cycle, that's just water evaporates, rains down, runs down. It's not a part of that, but it's part of that bigger cycle. And if you get rid of the water on a planet, all the tectonic activity stops. And if you get rid of all the tectonic activity, all the water disappears.
Why is that? Sorry, if you have time to answer that.
Because water lubricates the plates, and the plate tectonics provides the thermostat for the planet. And so if you shut down the thermostat, it gets too hot and all the water disappears. And if you get rid of the lubricant, all the tectonic activity stops.
It's like the engine of a car.
Yes, you need it all for it to work properly. Brett, you had a question.
So it's kind of a stupid, silly question, but when you were showing the pictures of what it would look like on different planets, and
Right.
sunsets, is it possible for like Tatooine style 2 twin suns to be possible on a planet, or is that just like
Yes, we have found planets that orbit double stars. So now, whether it's Tatooine-like and that you can actually have things living there that would see it, that's a whole separate question. I don't think that's possible, but we do know that there are planets that orbit double stars like that. We have found planets in that configuration.
What kind of rotation shape would that be gravitationally?
Well, most likely you'll have the 2 stars orbiting each other, and they're going to be relatively close together, and then the planet's going to orbit around them.
Would it be a deeper oval or more of a circle?
Depends. So the shape of the orbit depends on a lot of different dynamical things. They tend to form in circles, but the more things there are, the more bodies there are that interact, the gas, that can deform the shapes and make them more elliptical. So, and generally, the larger an object, the more circular its orbit's going to be, as a general rule. Yes, any other questions? All right, so we will be done then for now. I think we get back at 4:45. Oh, there's lunch in there somewhere. Huh? 4:30. All right, well, we're going to talk about is there life out there? And I will ask you, and everybody must commit, is there life or is there not? You got to have an answer, and you got to be bold enough to state it. Or at least raise your hand when I ask the question. So.
I mean, after the lecture, right?
No. That's going to be right up at the start. Well, think about it. Yeah, think about it. But yes. I'm not expecting you to have well-defined, but I am curious what you think and why you want it that way. I watched a little bit of it. I mean, not enough to know much of the details, but It was pretty cool idea though to go out and slam a rocket into a comet and see what happens. So.
Good tax dollars spent well.
Well, to the extent we're exploring things, yes, it's actually a useful mission in that.
Yeah,
But
what we've seen so far is like they slam a